Hello friends, welcome to another video of Technoveda Solutions on ST microcontrollers. So again we will be using the ARM Cortex M4 series only. So in this particular session we will be discussing about the program which is written for the mod counter. So in this program we will be counting up to 4 bits. So that is 0 to 15 we will be able to count depending on the mod value whatever we give. Till that the count is going to happen in the program. So let's begin, see how the program is written. So as usual, we will have a header file std.h for definition of these integer variables. We need that header file. Then we have three function prototype declaration here. One is GPI initialization, another two functions like LED bits and delay function. Now here we have all the declarations. So first, as usual, we'll be enabling the bus. Here we will be using two ports, that is port B and port C. Both the ports we will be using here. So what I will be doing is one LED I will be connecting on port C and remaining three LEDs I will be connecting on port B. However, it is not mandatory. We can connect to any ports available. So whatever the ports we want to configure, accordingly the LED hardware also should be connected. The pin what we define and the pin what we connect on the hardware should be same. Then we have a motor register for both the ports, port B and port C. We are enabling the motor register, they are defining the address of that. And then the output registers, because we know that the LED will be an output from the microcontroller. Then we have some variables declared here, globals. So one local variable value and another variable what mod value we want to give. So right now I have given 0x10. We know that 0x is a hexadecimal indicator. So the value of this will be 16, that is mod 16 counter. So the counting will be from 0 to 15. So these variables are declared for holding the bit values. 4 bits we will be using. So 4-bit variables I have defined there. Then in the main function, we'll define one local variable for the count. That is used for the for loop. That's a count used here. And then we will call the GPI initialization. And we know that in the initialization, if you go, so first we'll be enabling the bus for both port C and port B. So that is bit number 2 and 3 will be enabling. So 3 is shifted to that particular bits. Then in the motor register, we know that every pin will have 2 bits associated with them. So all the pins should be defined as output pins. So pin number 6 of port C, that is PC6. So the bit numbers are 12 and 13. So that we are setting to 0, 1. So bit 13 is 0 and bit 12 is 1. Similarly, for port B, 13, 14, 15 pins, we'll be using respective pins. So for 13 it is 26 and 27 bits, for 14 it is 28, 29, and for 15 it is 30, 31 of the respective motor register. Then coming back to main, after GPI initialization, we are entering the infinite loop. So wherein we are initializing the value to 0. Then we are entering the for loop here. Then we will be calling a function called LED bits. So the value, whatever the value is that we are passing as a variable here. And at the end of this bit porting, we are incrementing the value of that particular variable. Here we are incrementing the variable. Again giving a delay of some 5. This is again a random delay. Again we are going back for the for loop and continuing the execution. Let's see how exactly it works. Now here you can see the mod value is a terminal condition here. When count reaches the mod value, it will come out of the for loop. Till then the val variable will be incrementing. Now when LED bits are when the LED bits function is called, we'll see what happens in that function. Here we are taking the variable val as a local variable here. So all we are doing here is unpacking the number and assigning each bits to one particular variable, and we are also making sure that the value of that the bit value or the bit status is always at the LSB point. So if it is a B1, then I'm shifting it 1. If it is a B2, we are shifting it by 2. If it is a B3, we are shifting it by 3. That means B0, B1, B2, B3, all the variables will hold the 4 bits in their LSB status. Okay. So bit B0, LSB is having a bit 0, that is the LSB bit. B1 LSB bit is having the second bit of the total number, hex number. B2 is having the third bit of the hex number at its LSB location, and B3 is holding the MSB bit of the hex value at the LSB location. So here, for example, if my hex value, say it is say we have a value 1, okay, or we can take 2, okay, then in the binary we represent it as 0010, correct. So now this 0 will be at the LSB of B0, 1 will be at the LSB of B1, this 0 will be at the LSB of B2, and this 0 will be at the LSB of B3 after execution of this function. Then we have these bits available now, so we are porting those bits to the respective LEDs because LEDs are connected to the pins. So we are checking here if the bit is 0 or 1. If bit is 1, we are setting the LED, that means we are switching on the LED. We know they are all active low LEDs, so we have to make it low, reset the value to on LED. Okay, and similarly we set to off LED because they are active low. Okay, so if it is 1, we are making it 0, that means LED will be on. If it is 0, we are making it 1, that means LED will be off. Similarly, we are doing checking for each bit, and depending on the status of the bit, we are changing the status of the respective pin number, that is pin number 6, 15, 14 and 13. I have taken it according to the connections what I have done on the hardware. If you connect the LEDs to some other pins, accordingly you will be changing the pin numbers here. The rest all will remain same. Then you have a normal delay function here. So that delay function I have written here. You can see here the delay function. So it's just a random delay. So later in the coming sessions, we'll see how exactly a timer is used for generating accurate delays. So then once we have done the program, then we'll just build the program. So it's building. So now we can see that there is a 0 error, 0 warning. So the program has no issues. So now to execute this program, we cannot execute it here because I haven't connected the hardware right now. So I cannot execute it in this IDE, that is STMcube IDE. So what I do is I will port this this program to Proteus software, and we will try to simulate in that software. In the Proteus, one thing we have to remember, we need a hex file for that. So I need to generate a hex file. See here I have created a hex file here. It has built a hex file here, but by default it won't do that. So what you have to do is you just right click on the project, go to properties, and then in the properties under C++ build, you open this. Here you will have a settings. If you go to MCU post build outputs, here you have to enable these check boxes. By default they will be disabled. We have to enable this hex file generation, then click on the apply and close. Okay, then your hex file will be generated. Okay, now we'll go to Proteus. Already kept that also open. So okay, so in the Proteus already the connections I have done. So this is a microcontroller. You can see we have used a 401 microcontroller, and 4 LEDs are connected to PC6, PB13, 14 and 15, As they are active low, the cathode is connected to pin and anode is connected to power supply, that is 3.3 volts. Now I double click on this and then browse, load the hex file and then click OK. So it will load the hex file and then run the program. So now you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and then it will reset. So it will count from 0 to 15 and then it's going to reset back. Okay, now we can change the mod value and regenerate. We'll see that. Okay, so I can change the mod value and we can see the changes with respect to that. So now if I change the mod value, say I give 0a, that means it is a decimal 10, and then I build the program again. So now the LED again hex file is generated. Now in the Proteus again we have to reload the hex file, double click, browse, then again reload the hex file which is newly generated, then click OK. Now we will again execute this. Now we should execute up to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, then reset. Okay, up to 9 it will be counting 0 to 9 because it is mod 10 what we have changed it for. So it will be counting only 0 to 9. Okay, then we'll just stop this for a while. Then we should make sure that the microcontroller what you have selected is same, even though 4X series all are pin compatible, but we should be careful with that. And one more thing what you have to check here is that here when we go here we should set the frequency accord properly. By default it will be some other values, so we have to set to 16 megahertz. That's the microcontroller operating frequency right now. So accordingly you have to set the value and you can take the pick list from there. Okay, thank you. So that's it for this session. Hope you understood the program. If you have any doubt, any questions or any suggestions, you can always comment and like, share and subscribe the channel and set the bell icon to all.